Hey everyone, it's Justin again. This lesson is all about the volume of prisms and cylinders. Before we continue with this video, I want you to figure out the formula we can use for the volume of all prisms and cylinders by yourself. There are 2 GeoGebra links in your notes template PDF. Use those links now to try to find the answer to this key question, and then fill in the 2 boxes when you are confident enough to do so. Pause the video now and use your reasoning skills to work through this. By the end of this lesson, you will be able to calculate the volume of prisms and cylinders. First, we'll discuss where the formula for the volume of prisms and cylinders comes from. Then, we'll complete an example problem. So what is volume anyways? Well, how did you define it when you worked through the first page of your notes template a moment ago? What if I ask you to relate it to a glass of water? Hopefully you're thinking that the volume of this glass is basically just how much water we can fit in it. And if that's the case, then you're correct. We can define volume as the 3-dimensional space an object takes up. Now my question for you is, were you able to figure out how to calculate the volume of prisms and cylinders? What if they have bases like these? Here we have a regular pentagon, a triangle, a rectangle, and a circle. If only we knew how to find the area of each of these, then maybe that could help us. Oh wait, we do! We've already learned that in this course. Okay, so if we can find the area of these bases, then how do we find the volume of these 3D figures? Or, in other words, how would we fill these up with water? We would take the area of the base and multiply it by the height of the 3D figure. You can also think of this as the distance between the bases, if that helps you to remember it. So, have we figured out the formula for the volume of prisms and cylinders yet? That's right. It's the area of the base, which we'll call big B, or capital B, multiplied by the height of the prism or the cylinder, which we'll call big H, or capital H. There's one more thing I want to mention that you may have actually been wondering about. Why do you think we're using capital letters to represent the area of the base and the height of the prism or the cylinder? Well, have you seen lowercase b and lowercase h used anywhere before? Yeah, they're already in the formula for the area of a triangle and rectangle. So we need to make sure it's clear that these represent different values. This really might be your first time in a math course that you need to be careful and make sure that you're only capitalizing variables when you're supposed to. So keep an eye out for that. Oh, also, fun little hint, even though there are all sorts of shapes that could be the base of your prism, you're only going to be responsible for calculating areas of bases that are regular polygons, triangles, rectangles, or circles, if the 3D figure is a cylinder instead of a prism. Okay, that's it for my explanation. It's time to see if you can complete an example problem. This problem says to find the volume of the prism shown, given that the base is regular. Can you figure out a plan for how to solve this? Remember, the formula we're using is volume equals big B times big H, with capital V representing the volume of the prism or cylinder, capital B representing the area of the base, and capital H representing the height of the prism or cylinder. Pause the video now and see if you can try this on your own. Did you find the area of the base first? Since this base is a regular pentagon, we can use the 1/2 apothem perimeter formula to calculate its area. The other formula you learned for this 1/2 side length times apothem times number of sides, but I'm going to use the shortened form this time, where S and N are multiplied together and written as P for perimeter. Let's see here. Well, the apothem is 3 centimeters, and that's a good start. But now we need to find the perimeter of the pentagon. What do you think the perimeter of the pentagon is? 5 centimeters times 5 sides gives us a perimeter of 25 centimeters. Now that we've figured out what to substitute in for big B, what should we do next? You might be thinking that we should type this into a calculator and then substitute whatever we get in here for big B. But I actually want to avoid doing that just in case I have a decimal that would need to be rounded. We want to stay in the habit of keeping our numbers exact for as long as possible, just in case there could be rounding errors. So let's just substitute this entire expression in for B. Then we need to figure out what big H is. So what is the height of this prism? Hopefully, you said that it's 12 centimeters, since that's the distance between the bases. Let's substitute that into our equation. Now what should we do? We can type 1/2 times 3 times 25 times 12 into a calculator to get 450. And what about centimeters times centimeters times centimeters? What does that give us for our final units? That's going to be centimeters cubed. And just like that, we have our final answer. Now you can calculate the volume of prisms and cylinders. You know that capital B stands for the area of a base, and how we calculate that can vary from problem to problem, since you will see bases that are regular polygons, triangles, rectangles, and circles. You also know that capital H stands for the height of a prism or cylinder, and that's the same as the distance between the bases. Great job taking notes, Mia. It's been fun. Oh, and don't forget to complete the additional practice in your notes template before the practice game. See you next time!